Today I'm going to teach you about the transitive and substitution properties. First we'll look at the transitive property. So this says if angle A is congruent to angle B and angle A is also congruent to angle C, is angle B congruent to angle C? Hopefully you're thinking in your brain, yes. The way that we represent this is in the theorem, if two angles are congruent to the same angle, so B and C are both congruent to angle A, then they are congruent to each other. That's how we arrived at B being congruent to angle C. This holds true for segments as well. So we could just as easily say if two segments are congruent to the same segment, then they are congruent to each other. It's almost like you're cutting out the middleman. If you look back, we're cutting out angle A and saying B and C are congruent. Another way to think about the transitive property is this. Given that AB is congruent to EF and CD is congruent to GH, but EF is also congruent to GH, don't we actually know that all four segments are congruent, so AB is congruent to CD? The way that we say this is if two segments are congruent to two congruent segments, then they are congruent to each other. Again, this works for angles too. This should be reminding you of what we did this past week with complementary and supplementary angles. You're going to have two decisions to make again. First of all, are you talking about angles or segments? Second of all, are you talking about them being congruent to the same angle? Or are you talking about them being congruent to two congruent angles? The confusing part about this is that the substitution property is similar to the transitive property, but it's used slightly differently. Substitution is when you're just plugging in an equivalent statement. So there's not that same transfer of congruency like there is in the transitive property. Let's take a look at this proof together. So of course you're going to start with your givens. And it's always good to mark your picture. So we're given that angle 2 is congruent to angle 3, and we're told that angle 1 is complementary to 2. All we're trying to say though is that 1 is complementary to 3. So we're actually at, because angle 2 and angle 3 are exactly the same because they're congruent. So all we have to say for our last step is substitution. Let's compare this to a proof that involves the transitive property. Okay, so again we're going to start with the givens. Pay attention to the fact that we're working with segments here, not angles. And I'm already noticing that we've got FG congruent to KJ, and we've got GH congruent to KJ. So I'm noticing that KJ is occurring here twice. That's a pretty big clue to me. The transitive property says if two segments are congruent to the same segment, then they're congruent to each other. So I can now say that FG is congruent to GH. For my reason, I can't just write transitive property. That was really nice when we could write that for substitution. But I'm going to say if two segments, because again we're talking about segments, not angles here, are congruent to the same segment, then they are congruent to each other. Now that's not what they were asking me to do in the proof, so I'm still going to have another step in my proof. But I had to put that step first before I could say that KG bisects segment FH. You should be thinking bisects means divides into two congruent parts. Now that I have those two congruent parts marked, FG and GH, I'm ready to finish the proof with the bisects. So I'll go ahead and say KG bisects segment FH. And the reason I don't want to start with the bisects, I want to start with if a segment divides a segment into two congruent parts, then it bisects the segment.